All right. So, Zachary, tell me, what is the green line called?
The normal too.
Right, this is the normal. What is the blue line called?
The boundary line.
All right, Vani, what is the waiter? Vani, the boundary line and the normal has to be what angle? Like apart. What
90
angle?
degree.
Yeah, 90 degrees. Amira, what I call this ray over here,
So the incident rate,
right? Jadon, what would I call this angle here in the middle?
Oh, you can repeat?
What I call this angle here? What's the name of the angle?
Repeat again.
Damn. All right, anybody want to remind Jadon what this angle would be? Anybody? That angle.
The angular incidence.
Yeah. This is the angular incidence. All right, Jadon, try to recover, right? So, Jadon, what do you call this ray? This ray over here. This ray over here, the other ray.
And that also for the incident rate.
No. Jadon, yeah. Yeah, you had to lock in, man. You had to lock in. That's what R.
Refracted rate, sorry.
Right, because the undergoing refraction.
Yes.
Refracted ray. What would I call this angle?
The angular refraction.
Right. In this question, I'm going from what to what? I'm going from what to what?
Water to air.
I'm going from water to air. Am I going from more dense to less dense or less dense to more dense?
More dense to less dense.
Guys, anytime I'm going from more dense to less dense, what does the refracted ray do?
Bend towards the normal.
Does everybody agree with that? More dense to less dense. Is it bend out? Is it bend towards the normal or bend away from the normal?
Then away to
Right, Nikolai. If you're confused, look at the diagram, right, Nikolai? Which angle looking bigger? The angular incidence or the angular refraction? Which one looking bigger?
The angular refraction.
Right. If it just went straight through, it would have looked like that, and this angle would have be the same. But because it bend away from the normal, the angle a little bigger. Understand?
Yes, sir. My apologies, sir.
That's okay. So if it's more dense to less dense, then the refracted ray, it bends away from the normal. All right. Since I'm going from water to air, which formula I should use? Guys, what's the formula I should use here? I'm going from water to air. Anybody?
the Ni sin I is equal to Nr sin R.
Right. Ni sine I is equal to Nr sine R. Somebody. All right, Jadon. N Ni. What is Ni? First of all, what is N, Jadon? What does N stand for?
Um, N stands for
Starts with R.
refractive index.
Yes, N stands for the refractive index. And you see the NI, it stands for the refractive index of wherever the incident ray is. Where's the incident ray, Jadon?
Um, in the water.
Right, so what's the refractive index of water?
It would be 1.
No, that's for air. For water is 1.3.
Oh,
This is air, this is
1.3,
water. Right, I don't put brackets. Brackets. I don't put brackets, right? So 1.3 sine. Do we know what the angle of incidence is? Somebody
Yes,
tell me. Where's the angle of incidence?
30 degrees.
Right? What is NR? That stands for the refractive index for wherever the refracted ray is. Where's the refracted ray? Where's the refracted ray, guys? Find people real dead. Amira, where's your refracted ray? Amira, where's your refracted ray? Is it in water or air? Can I hear an Amira? Vani, where is the refracted ray? Is the refracted ray in air or water?
So water.
The refracted ray?
No air.
Amira, let me check your work in this Let me check it out.
So I feel that wrong.
Okay, well, you drew the diagram wrong. The diagram is drawn in improperly because it's a good thing. Well, I mean, it's a good thing all this time I'm all working, right? The only way I could see where you're doing wrong is when you send me working. Wait. So like Amira, for your diagram, I see that you draw that's wrong, eh? You can't do that. You can't do that. It has to meet at they call this the optical center. They have to meet at this point. So Amira, you draw the diagram wrong. Um,
Okay, so
you label it correct, I think. So like the incident ray, yeah, and then the refracted ray. Mm-hmm. So Amira, where is the refracted ray? So like Amira, what ray is this? What ray is this?
incident ray.
Where's I in? Where is that?
Any water?
Right? And then we look on this side. What is this?
Refracted ray.
To the refracted ray in?
Air.
Right. So the refractive index for the refracted ray is gonna be what? Where's the refracted ray? Remind me. The refracted ray is in what? Amira?
Certain air, so it'll be NA.
Right. So that'll be 1. And do we know what R is? Tell my guys, do we know what R is? A real dead boy. What going on?
Also,
Now we don't know what R is. Right, so Amira, you want to tell me what happened next? So this is just maths at this point. This is not physics, it's just maths. So Amira, I want you to help me. Amira, what's the next proceedings? We're gonna proceed next.
So well, I put so I put 30.
Let me check. Let's see what you do here. All right, so something's wrong here. So Amira, let me try to understand what's happening, right? So do you understand that the incident ray is in the water
Yes, sir.
and the refracted ray is in where?
Air.
Right. But in your formula, when you was writing it, I see you put 1 by sine 30. You know why that's wrong? I see you put 1 by sine 30 instead of 1.3.
So because one is for water,
Now look at this. Check this out. 1 is for what?
air.
Yeah, so that was wrong. And well, they make the same mistake on the other side. They say 1.3 sine theta r. It would not be 1.3, it would be 1 because the refracted ray is in air and the refractive index for air is 1. So it's supposed to look like this so far. You understand?
Yes, sir.
How much of you guys was able to get to this point? Let me know.
Yes, sir, I was.
All right. Nice, nice. Good job, Shayna. Vani, let me know if you reach this point or not.
Yes, sir, I had that.
All right. How about the rest of you guys? Adil, Nikolai, Drew, let me know. Were you all able to reach this point? Take that as a yes. All right, so Mira, how am I going to make R the subject of the formula next? What am I going to do? All right, so Amira, if you're genuinely feeling a little lost, talk to me. But,
So you're
but,
gonna put, so
mm-hmm.
you're gonna flip it and put one sign R in front. Well, sign R.
Okay, tell me, sin R is equal to, Amira. So you'd say sin R is equal to what?
1.3.
Okay, but what happened to the sine 30 though? What happened to the sine 30? So it could be sine R is equal to 1.3 sine 30. The 30 can't just disappear. Right? So sine R is equal to 1.3 sine 30. So I didn't change anything here, Amira. I didn't change anything. I just flip it around. Maybe it might be easier if I flip it around. Right? So I just flip it around, right? 1 sine R is just sine R. So did I lose anybody at this point? I lose anybody or we still on the same page?
Same page, sir.
Amira, I need it to be real honest with my like. If you're lost, you have to tell me. You have to tell me now, Amira.
So I understand.
All right. So Amira, we want to find for the angle R. So what how to do next?
Mm. So you're gonna divide it.
Nah, you're not gonna divide. I'm gonna divide. We just have sine R here. So anytime you have sine of an angle and you want to find the angle, you have to find what? You have to find what? So I have sine R here. And I want to find for R. So I'll have to apply the what function. What is the opposite of sine? Right, so Amira, I'll help you out, right? So sine inverse. You have to use sine inverse. Anytime you're trying to find an angle, you'll have to use sine inverse. So R
Okay.
would be equal to sine inverse of 1.3 sine 30. So plug that into the calculator and let me know what you get. How much of you guys was able to figure this out?
Me, sir.
All right, nice. Zachary, Vani, Drew, like I'm gonna
Yes, sir, I was able to.
Yes, sir, I had that.
Shina, yeah?
Yes, sir.
Adele, did you get a chance to try the questions for homework or not?
Not sure.
No? Okay. Well,
So
I mean,
I think decimal places is supposed to have the thing at or what?
two. Two decimal places or three SF is fine.
40.54.
Let me just verify that. Right, so Amira, it seemed like the maths trouble in you, more so than the physics. Is the maths? Is the maths giving you trouble? Right, so that'll be 40.54 degrees. Yeah, that's correct. All right, so let me just run through this thing one more time, Amira, and make sure we like locked in. Make sure like make sure we 100% understand this. So you know what I'm gonna do, Amira? Well, I'm gonna erase this whole thing, and you're gonna tell me how to proceed from the start, because we're leaving until you understand this. All right. So Amira, what formula to use here? What formula should I use here? As the first thing we should start off with, what's the formula I should use? Adil, pay attention. So Amira, what's the
NR
formula?
sin I equals NR sin R.
Right? Ni sin I is equal to Nr sin R. Now, N stands for what? What does N stand for?
Refractive index.
Right? And I stands for the incident ray. So this means the refractive index of wherever the incident ray is. What's the incident ray?
In water.
Right. So what are we going to put for the refractive index?
1.3.
Right? Do I know the angular incidence?
No.
You sure? You sure? Check the top. Check the top. Check the information I was given.
Oh, 1.
Nah. What is one?
If it's an air.
Wait, no, take your time. Take your time. Take your time. So Ni stood for the refractive index. Sin I. What do you think I is?
The angular incidence.
Right. Look at the information that was given. Were we given the angle of incidence?
T.
Right? It was given 30. Next part now. Nr. You tell me what to put for that. So NR.
So you put in 1.3. No, wait.
Whoever you tell me, I gotta explain to me. Why you want to put 1.3? Explain that to me.
Wait.
Say that again.
Wait.
I'll wait and I'll wait.
So you put in 1
Why I put in one?
because it's in the air.
Yeah, it's in the air, right? So you gotta put one. The refracted ray is in air, right? And do we know the angular refraction?
No.
Nah, so I'll leave that blank. What do we want to do next?
Sine inverse.
So tell me what to write next. I'm gonna see where you're gonna tell me. You tell me what to write next.
Sine inverse. Brackets. 1.3 sine 30.
And that'll be equal to what?
40.54.
You're not wrong, right? But that entire thing, when you do this, you're solving for what? What are you solving for? When you find sine inverse at 1.3 sine 30, what are you finding for?
The angular refraction.
Right. So you put that equal to R. And the last line, you would say R is equal to the angle you get. So you get 40.54, right?
Mm-hmm.
Cool. And if we are comparing this, Nikolai McLeod.
So,
Yeah, Mira?
but I put that anything I send you, I just think I mix it up.
If you mix it up and you don't get the same answer, you're gonna get it wrong.
So I have I is equal to 30, R is equal to 40.54 degrees.
Um, I'm not seeing. Okay, you talking about for the next question because I gave you all two questions. I used this. I used this question to come up with this question. So the 40.54 would be over here. You're talking about for the next question, but in your working for the first question, that's wrong. You you
Okay.
the working is incorrect, and the final answer is wrong. I want you to understand why you're wrong, so that we can move on. And next time you do that question, it will be like, oh, okay, let me think about this. Here what? I want you to look at your working, and I want you to tell me why it's wrong. Tell me why it's wrong. See if you can do that.
Okay, first, so I put 1 by sine 30 instead of 1.3, and then I never make R the subject.
Yeah. So that's essentially it. So you gotta be very careful. So here what, Amira, you're not getting away. You're gonna help me do part three now, right? We're gonna make sure you understand this. Adele, let me know if you're confused or if you understand this thing.
Did you go through it one more time?
All right, so Adele, do you know what Snell's law is? The formula for Snell's law?
Yes, sir.
What's the formula?
The formula is Ni sine I is equal to Nr sine R.
Right. What does N stand for?
Refractive index.
Right. So Ni means the refractive index for the incident ray. Like wherever the incident ray is, you're gonna use that refractive index. So Adele, when you look at the diagram, where is the incident ray in? Where is it? So the boundary line would separate the mediums. So where is the incident ray in?
The water.
Right. So we're going to use refractive index of water, which is 1.3. So I'll say 1.3. I stands for the angle of incidence. They gave us that as 30 degrees, so I'll plug that in. Now, we move on to the right-hand side. NR is the refractive index for the refracted ray. So where is the refracted ray, Adil?
In the air.
Yes, so you'd use the refractive index for air, which is 1. So I'll say 1 sine R. I don't know what the angular refraction is, so I'll leave that blank for now. So if I want to find for R, I would need to find sine inverse at 1.3 sine 30, and that would give me R. Yeah, tell me if you're confused. Maybe like from here to here might confuse you.
Yeah, that part.
All right, maybe I could write it a bit differently. You do trigonometry in maths yet?
We do a little bit in like form 2, but not much.
Okay, I'm talking about like SOHCAHTOA, sine, cosine, tan.
Yeah.
All right. So maybe if I simplify this, it will look a little simpler. So 1.3 sine 30 degrees. What is 1 by sine R? What is 1 by sine R?
Sine.
What is 1 by anything? Like say 1 by 5, 1 by 10.
The number
Right, so what is 1 by sine R?
minus 0.46.
Nah. Sine R. 1 by sine R is just sine R. Here we're asking, right? What is 1 by anything? Like say 1 by 10. What is 1 by 10?
10.
What is 1 by sine R?
Oh, yeah.
Just
Sine
be,
R.
just be sine R. So right now, I have sine R. Anytime you have sine of an angle, R is the angle, and you want to find for the angle, you would need to find sine inverse of whatever is on the other side. So to find for R, I'll find sine inverse at what? You tell me. Adel?
Yeah.
I'll find sine inverse our watts.
1.3 sine 30 degrees.
Yes. And yeah, you get 40.54. You get 40.54. Right. McLeod. McLeod. I think I'm saying that correct, I'm not sure. Yeah. You there?
Yes, sir.
Right. Does it make sense? Like, does our answer make sense? If you compare it to the angular incidence, does it make sense?
Yes, sir.
Yeah, it does make sense because which one's supposed to be bigger?
The angle of refraction.
Exactly. The angular refraction is supposed to be bigger, and we did find it to be bigger. All right. So Amira, like I say, you're not hiding, you know. You're not hiding. We gonna get this. We're gonna get this one in physics, you know, for sure. All right. First things first, Amira. What's the formula I'm gonna use? What is that formula?
Mm. So you can use Ni over sin r. Sin I over sin r equals the nr.
Um, n Not quite. Say that again. Which formula you wanted to use?
Nr equals sin I over sin r.
Right. You can only use that formula when you're going from A to something else. But in this example, we're going from where to where?
Water to air.
Right. You're not going from air to something, you're going from water to air. So the safest formula to always use is like the safest formula is Ni sin I is equal to Nr sin R. Right. So what next, Amira? What do you want to do next?
Um,
Take your time, we can figure this out.
I don't know.
Nah, don't say you don't know. You can figure this out. We need to we need to fill in the variables. So like what is Ni? What is Ni? What is Ni?
30.
Okay. What does N stand for? What does N stand for?
The
Remind me.
refractive index.
Right. Not the angle, but the refractive
Oh,
index. N is the refractive index. Now you see a little eye in the bottom. So you're going to look to see where the incident ray is. Where's the incident ray? In the
in
diagram.
water.
Right. So what are you going to use for the refractive index?
1.3.
You're going to use 1.3. Wait, come on a second. And yeah, just fix something. Yeah, you're going to use 1.3. Okay, what next? So we're going to use 1.3. Then I'm going to write sine I. Do I know what I is?
Yeah,
What's I?
30.
right? I is 30 degrees. That's an angle. Right. Do I know what NR is?
Yes.
Nah. What the question saying?
Okay.
So what the question saying there?
To find for NR.
Right. So we gotta find for NR. So you're gonna leave that blank. Gonna write back sine. Do I know what R is?
Yeah.
What's R?
40.54.
Right. Okay. Let's continue. So again, this is just strictly maths. This is none of physics. It's just maths, not the maths at this point. So what do we need to make the subject of the formula here?
NR.
NR. Okay, so what do you think I should do next? Tell me, where's NR? Where is NR? NR is on the left-hand side or the right-hand side? Where is
Right
NR?
hand side.
Right-hand side. All right. So,
So put it on the left hand side.
all right. It's not as simple. If you're trying to make something the subject of the formula, then you want it to be the only thing on that side. So
Uh,
right now, NR is on the right-hand side, but you want it to be the only thing there. Is it the only thing on the right-hand side? Is it the only thing here?
no.
Wait, also have there.
Find 40.54.
And N is being added to that, multiplied by that. What happened in there?
Multiplied.
Right. So if I wanted to cancel this off, what would I have to do?
Divide.
Right. So I'll divide by sine 40.54 on both sides. Now you can't just say divide by sine, eh? Sine 40.54 is an entire thing. So sine 40.54. So this and this would cancel off. See, and that would cancel off. And Amira, what could I write in the next line?
NR is equal to 1.3 sine theta divided by sine 40.54.
Correct. So plug that into your calculator and you get your answer. That's it. That's it.
I get 1.000326888.
So if you round that off to one decimal, I mean two decimal places, where we are.
1.0.
Yeah, you get 1.1.00. Now let me ask you a
Yeah.
question. Amira, does that make sense? Let me look at the question, right, Amira? What were they asking us to find for in this question?
NR.
What is NR? What is NR? Remind me, Amira. What does N stand for?
The refractive index.
Right? And the little R means that we're looking at the what ray?
Refracted ray
Where is the refracted ray?
in the air
So they wanted us to find the refractive index of what?
of air.
Right. What do we know the refractive index? What do we know the refractive index of air to be?
1.
Did we get a?
Yes.
Yeah, so everything making sense. Everything makes sense. So I hope you understand that. Adil, let me know if you cooked or if you understand.
Not sure I understand.
All right, all right. I'm gonna just do a roll call quickly. Jadon, uh, be honest with me. All in all, it could be honest with me. Like if we feeling cooked, just tell me. But if you understand, you actually understand, let me know. I know the maths will give people trouble, but let me know if you understand.
Yes, sir. I understand. It's just like I feel like my problem it just lies with reading the question properly, with remembering which is like the just where to substitute the NA and NW. But other than that, I understand the formulas well.
And I think your problem might also be practice, because like I mean I give you
Yeah, in
homework, but you
practice.
do the homework.
Nah,
Like
I didn't get to do it.
like you see, look, Amira do the homework, she sent me she answer, and I was like, okay, I see where you do wrong. We could fix that. If you don't send me your homework, I can't tell you where you had to fix. I don't even know where you had to fix. So try to practice. Um Nikolai, Sheena, um um rest of you guys, Vani, Drew, Nikolai, Zachary, we good? We good with this homework?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, bet.
Sir,
Uh,
if I was supposed to compare subjects, I would choose this over math, sir.
I don't get it wrong. I mean, that's valid because you're using maths here. Like physics is very maths reliant. So I mean, it come like you, Nikolai, it come like you actually use any maths for something. Come like you actually use any maths.
Yes, sir.
All right. So let's go over critical angle and total internal reflection now. Now I went through it over here in class briefly, but I feel like all your brain cells was like, this is to the end of the class and everybody was tired, and I was like, nah, I can't understand this. First things first, guys. Anytime you're going from a anytime you're going from a more dense to a less dense, what happens? Somebody tell me, anytime you're going from more dense to less dense, what happens?
So the refractive ray bends away from the normal.
Right. Refracted ray. Nikolai, remember this, right? The refracted ray bends away from the normal. Now, this is the only time total internal reflection can happen. So the topic we're looking at today is critical angle and total internal reflection. And total in like these phenomenons, what's in these phenomenons could only be observed if you're going from a more dense to a less dense. That's the only time it has happened. When you're going from a more dense to a less dense medium. That's the only time total internal reflection could happen. Let me just verify that. Yeah, that's correct. Hmm. So, by the way, guys, happy Pi Day. I forget that today's Pi Day. Yeah, 3.14, you know what I mean? The third month, 14 day, 3.14. Yeah,
Okay, happy Pi Day, sir.
thank you, thank you. I figured that my girlfriend will point this out to me. Yeah, so total internal reflection could only ever happen when you're going from a more dense to a less dense, and you'll see why. So let me just examine a very typical scenario. So as soon as I draw the lines, I want you to tell me what's what's the name of the line? What's that green thing over there? What's that?
The
What's that?
normal,
What's this blue line over here?
the boundary.
Cool. What is this over here? What's that?
The incident rate.
Yes. Do you guys know why I'm calling that the incident rate? I see people unmute bad in here earlier. I didn't know why we calling that the incident rate.
Because the arrow pointing in that direction.
Yeah, it pointing towards the optical center. Like pointing towards it. So it's like incoming incident. If I wanted to draw the angle of incidence, would this be correct? Would this be the angular incidence I?
Let me see.
Amira, that correct or nah?
No, sir.
Nah, the angular incidence is formed between the incident ray and the normal. So this would be correct. Theta I. And this is the incident ray. Now, let's just say that this over here is water. So this is water, and this is air. Now, if I'm going from water to air, tell me what is suitable. Is this suitable? Tell me, guys, if I'm going from water to air, would the refracted ray look like that?
Let me
Guys,
see.
Nikolai, Vani, Drew, Amira, like, I
Nah.
don't, okay, would it look like this?
I see.
I want Nikolai to answer this. McLeod, Nikolai. If I am going, if I'm going from a more dense to a less dense medium, would the refracted ray bend towards the normal or bend away from the normal?
It would bend that way.
Right, so you go bend away. So maybe there might be like a safe bet. Yeah?
Yes, sir.
And I call this theta R. And this would be your refracted ray. Now, Nikolai, here's what we're going to do, right? Here's what we're going to do. We are going to increase the angular incidence. If I increase the angular incidence, what do you think gonna happen to the angular refraction?
It will bend more away from the normal.
Perfect. I like how you're thinking. Oh, that makes sense. Like if I were to take this and I were to increase it, make it bigger, what would happen to the refracted ray? So, guys, here we're asking, if we take the incident ray and we pull it even more away from the normal, what's gonna happen to the refracted ray? Is it gonna
It
get
will bend
smaller
more
or is
towards the
it gonna get smaller or bigger? Okay, I feel like some people are just very confused. Let me show you what happening, right?
It get bigger.
Yeah, watch. Look at what's gonna happen. If I make this bigger, this is gonna pull even more away from the normal. Oh, let's see that.
Yes, sir.
Yes.
Can I hear enough people? Amira, you there?
Yes, sir.
All right, so Amira, I'm gonna make this bigger. As I make that angle bigger, we're gonna have to refract the angle for the angular refraction.
It will get bigger.
Right, it will go even more away from the normal. That makes sense? It will just keep going more and more and more away from the normal. You see that, right?
Yes, sir.
All right, so I'm gonna draw that on the diagram here for us to see. So I'm going to make the angular incidence bigger. You will see where I'm going with this. And by doing that, the angular refraction is going to get even bigger. Now, are you all noticing something? Tell me, are you all noticing anything about the angular refraction?
Yes, sir.
The angular refraction getting closer and closer and closer to what?
Boundary line.
Anybody else seeing that?
So this place real quiet, sir.
I don't know what's going on, boy. Crazy. Right? As theta I gets bigger, um, theta R, wait, the refracted ray bends what's a good way to say this, boy? So as theta I gets bigger, the refracted ray bends what?
But okay. Or
Little bit more inwards.
I like further away. Amira, is that good? You say inwards? I think you're saying that because yeah, it looking like it going into the water. That's fine, but I will use further away. The refracted ray bends further away from the normal. Zachary, if you look at the refracted ray, it looks like it is approaching the what? What is it approaching? It looks like it
The
approaching.
boundary line, sir.
Right. It is starting to approach the boundary line. Cool. Now, this is where the critical angle comes into play. So, Nikolai, if I increase the angular incidence a little bit again, what's going to happen?
it'll end up being on the same line as the boundary line.
Perfect. So, I increase the angular incidence a little more. You know what happened? It caused the refracted rate to be in line with the boundary line. And that caused the angle to be what, how much degrees? What's the angular refraction now?
90 degrees.
Yep. So at this point, you would call this the critical angle. And the critical angle is the angle that causes the angular refraction to be 90 degrees. And this would be theta r. So I'll make a little note about that. The critical angle is the angle that causes the refracted ray to bend 90 degrees away from normal. Right? So right now it is along the boundary line. So does everybody understand what the critical angle does? Yes or no? Let me know if you understand now or not.
Yes, sir.
Yes, sir.
So like at the critical angle, what's the angular refraction?
90 degrees.
Perfect. So at theta C, theta R is equal to 90 degrees. I hope everybody understand that. And let's look at the final thing now. Let's look at the final scenario. So Nikolai, if I were to increase theta I even more, what's gonna happen? What do you think gonna happen?
There'll be a total internal reflection.
Right, guys, Adel, Vani, Nikolai, Drew, Amira, everybody. And if I were to increase this, it will cause the angular refraction to get even bigger.
Yes, sir.
Yeah, but right now, the refracted ray is along the what? It's along the what?
Three
The
pound.
boundary
Boundary
line.
line.
Right. But if I increase the angular incidence a little bit again, you know what's gonna happen? It's gonna move, it's gonna drop, and it's gonna go into what? It's gonna
Into the
lead.
water, so
The
Into the
Right.
water, sir.
water.
Right. So instead of going from water to air now, you're going from water to water, and you're gonna experience something called total internal reflection. So here what, it don't matter what the angle is, once it is past the critical angle, you're gonna have total internal reflection. So let me make a note about that. So this is how it works. Total internal reflection. So you'll have an angle here, theta I, and you'll have an angle here, theta R. And we won't call this, and we wouldn't call that the angular refraction anymore, right? We'll call that the reflected ray. So this is a reflected ray. And I would call theta R the angular what? What do you think? The angular what?
Wouldn't it be
reflection.
Yeah, angular reflection. Yeah. Yep, I remember it. Yeah. Mm-hmm. Once you go past, okay, I make it sound a bit better. Once you exceed theta C, total internal reflection takes place. So I have a question, guys. If it is total internal reflection, that means that theta I would be equal to what? Think, guys. If it's reflection, it means that theta I is going to be equal to what?
Theta R.
Theta R.
Right, because it's being reflected, and so the angles are going to be the same. If you don't understand this, tell me now. Jadon, Amira, Adil, let me know, guys. If you're confused at all, just talk to me and let me know. If you understand, let me know. Let me know too. So I know what's going on.
Yes, I understand.
I
Yes, I
understand.
understand.
All right, bet. Bet. And you're probably wondering, well, so where's the critical angle for water? The critical angle for water is 50.3 degrees. I'll show you how to find that in the next slide. But take this in.
one question, sir? Would they give that any question? Or they wouldn't?
I don't think they would. I don't think they would.
Oh,
You have to find that. You have to find the critical angle. So I'll show you how to do that now. So I hope everybody understands the concept. If you keep increasing theta I, the angular refraction is going to get bigger. So that's this scenario over here. But it's going to reach a point where you increase it so much that the refracted ray is going to be in line with the boundary line. And if you increase it past that point, you know what's going to happen? Something called total internal reflection, where the angular incidence is going to be equal to the angular reflection. Hope you understand that. Are we okay
yeah.
with this?
Yes, sir.
I don't know why everybody's so dead, boy. I don't know.
Yes, sir. Like this angular refraction and internal reflection affecting them bad, sir.
I don't know. Nicola, I swear if this was our live, everybody ought to be talking. I don't know. I don't know what this is. Why? Maybe it's the morning vibes. I feel like it's the morning vibes. I mean,
Could be.
is that Saturday morning? People want to sleep and thing. Yeah, they had to do physics. I know, I know, I
So,
know.
but if I get my end marks, sir, my physics marks can be higher than my maths marks, sir.
Damn. Wait. Physics easy, you know. Like genuinely, it's really,
Yes, sir.
Yeah.
And it take me too long to realize that's it.
Hmm. So finding the critical angle for water. So finding the critical angle when going from water to air. So I want somebody to remind me. Vanny, I'm not hearing from you, Vanny. Vanny, why you leaving me hanging like this, girl? Vanny, I'm not hearing you. Come on.
Sorry.
Yeah, boy. I don't know why you give me that treatment, boy. Hey. Right, so Vanny, remind me. At the critical angle, at the critical angle, what is the angular refraction? Remind me. Do you remember? Yes or no?
No.
Wait, boy. Vanny, you was paying attention on that.
Yes, I was paying attention, but I remember.
Okay, well, Vanny, let me go through this again, right, Vanny? And for anybody that not paying attention, lucky now. Jadon, Zachary, Shayna, Amira, Nikolai, Adil, Vani, Nikolai, Drew, everybody. I'm gonna go over this thing one more time. So Vani, anytime you're going from a more dense to a less dense medium, what happens to the refracted ray?
It bends away from
Right, it would bend away from the normal. Bend away from the normal. So if that is the case, Vani, which angle is going to be bigger? The angular incidence or the angular refraction?
the angle of refraction.
Right. So Vani, if I keep increasing the angular incidence, and my angular refraction gonna get bigger?
Yes.
Right. Now there reaches a point. Vani, you notice that this refracted ray getting closer and closer to the what? It getting closer and closer to what?
The boundary line.
It getting closer to the boundary line. Correct. This is the boundary line. It's getting really close to that. So if I increase this any more, what do you think will happen?
The angle of refraction will reach the boundary line.
Perfect. Like so. And at that point, you would call the angle of incidence the critical angle. You understand?
Yes.
And at the critical angle, what is the angular refraction?
90 degrees.
Perfect. And if I were to increase this any more, it's going to go from water to water. And at that point, you're going to have total internal reflection. So, like, I hope that makes sense.
Yes, sir. Yeah. It makes sense.
Right. All right. So, let me see if I was paying attention. Jaden, at the critical angle, what is the angular refraction?
90 degrees.
All right. All right. Now, if I just wonder why as I call upon every single person, is because, like, I myself, like, okay, if I'm in a class like this, I'm not gonna pay attention unless somebody call me. And I feel like that's like a universal thing. Like if people in an online class, they're just gonna be doom scrolling on TikTok. So like unless I call all their names, or they might probably just be doom scrolling or sleeping.
That's it. I could be paying attention, sir.
Well, I know you could be paying attention there, but like generally speaking, I mean, if idols do it, I wouldn't doubt all idols do it.
Okay.
Right.
Well, you have a point there.
Like for me, it'd be real hard for me to pay attention. So like I just try to practice what I think would work on myself. Because I feel like Isaac a real bad case. So I mean, if it could work on me, I feel like it could work on you guys. But Nikolai, I know you're disciplined. Probably more disciplined than me. So, guys, I'm just gonna draw a little example here. So we're going to call this water. This is going to be water. And this is going to be air. So everything over here is air, everything over here is water. I want somebody to tell me what would I call this ray? What would I call that ray? The refracted
The
ray.
refracted ray.
All right, big up you. Quickly, guys. It looks as though the angular refraction is what? What's
90
the angle?
degrees.
So if the angular refraction is 90 degrees, what would I call this angle over here?
Critical angle.
Perfect. Zachary, you're real paying attention, boy. Big up you. Zachary and Nikolai, they're giving up like nice guys. This is the incident ray. And this is the refracted ray. So I'm going to call upon our very favorite person for this, Amira. Amira, you're gonna help me with this, Amira. You're gonna help me with this.
Okay.
Yeah. So Amira, just remind me again, where's this angle? What's the angle?
90 degrees.
Yeah, this angle is 90 degrees, right? Cool. So Amira, in this example, we're going from water to what?
Water to water.
Nah.
Water to air.
Right. If it was water to water, then it would be like it'll literally be water to water now. It'll just be
Okay.
water. But like right now, it is along the boundary line. Right now, it's at the threshold. Right now, it like is neither air or water. But for the concept, let me just say it's in air, right? Because it's not entirely in the water. If it was in the water, it'll look like this. Yeah. And so you know that song, In the Water. Amira, you know that song?
Yes.
Lady Lava sing that?
No.
With your
Uh,
chest, with your head. What's the name of that song? I wonder who sing that song now, boy. Sing that song.
that would be good.
Every time you talk about water, I just thinking of Iowa George. I don't know why.
Yeah. All right. Is Sorrow? I never hear. I didn't know. Wait,
Yes, sir. I know seeing that. I have no clue who's that. I thought it was that girl who sang that.
I could have swear it was a girl too, boy. What is jail is a man? A man sing that song, boy. Wait, you learn something new every day, boy. Wow. Wow, wow, wow. So Amira, what formula should I use here? Good old formula for a fraction.
Um, Ni sin I equals Nr sin R.
Right. Now, Amira, we have the angle of refraction. What are we missing?
The angle of incidence.
Right. Now, here what I'm saying, right? Like this topic is literally finding the critical angle. So I need you to understand that theta C, this is actually theta I, but we have a special name for it. So it might be a bit confusing, but here what I'm saying, right, Amira? The critical angle is a special angle of incidence that's going to give you an angle of 90 degrees, an angular refraction of 90 degrees. So here what I'm saying again, right? Theta C is really a value for angle of incidence, but it's a special value because at that value, you get an angular refraction of 90 degrees. So I hope I didn't confuse it too bad there. So
So
Amira,
I
yeah,
understand.
you understand?
Yeah.
And here what? To make sure you're not confused, let me just put on the refractive index of water here and the refractive index of air here one time. What's your refractive index of air?
1,
What's your refractive index of water?
1.3.
Let me not stick. We know that. All right. And if you want to make it even like less confusing, you know where you could change Na to? You could change that to Ni. Because I'm not saying change that to Nr. Because you know where the refracted ray is? Well, we say that is in air, right? And where is the incident ray? Selma Amira, where's the incident ray?
In water.
So I could change this to Ni. Yeah. So we shouldn't be confused now what to write next.
Now you're gonna put 1.3 sine, and when I don't know what is the angular incidence, so and then equal to 1.
Wait. We're trying to find the critical angle. Now the critical angle is a special thing, right? The critical angle is called theta c. So you know what we're gonna do? Instead of writing I, we're gonna write theta c. But yeah, the theta c is the angular incidence. But yeah, we're treating it like as a special thing. So let me just call it theta c. You
Okay,
confused
so
about that or?
no, sir.
All right, and then we're gonna write equal to what? Equal
So,
to
but the theta c, right? It enters equal to the angular incidence, but you just had to write it there because, like, that's the proper terminology for it.
yeah. Because we're trying to find the critical angle. At the critical angle, theta I is equal to theta c. So like,
Okay.
okay, let me just say I have an angle of 50 degrees here, right? We know that'll be theta I. Theta I is 50 degrees. Yeah?
Mm-hmm.
But if it gives you an angle of 90 degrees here, then that's the special name for that is critical angle. So if 50 degrees is the angle of doing that, well, I'll call the 50 degrees theta c. We know it's an angular incidence, but if it given you if it given you 90 degrees over there, you have to use a special name, and that would be called the critical angle. So we are trying to find the critical angle. So instead of writing I, I'm just gonna write theta c as the proper name for it, and that'll be equal to what?
That will be equal to 1 sine 90 degrees. Well, 90.
Okay, before we do anything, let's just simplify, right? What is 1 sine 90?
Mm. So 1 and 1.3.
1.
It's just 1. 1 sine 90 is just 1. Amira, check in the calculator. 1 sine 90.
1.
Yeah, that would just be 1. Right. Now you have to be very careful here. Very, very careful. This is just maths at this point. So Amira, we are trying to find for what here?
The critical angle.
Right, we're trying to find for theta c. Let me see what you're gonna do. What do you think? What would you do next?
So, okay, I would try to make sine theta c the subject.
Yeah, you had to make sine theta c the subject first. So how you gonna do that?
So we're gonna divide by. So I don't know if we're gonna divide by 1.3 or 1, but we're gonna divide.
You had to divide by 1.3 because you would have to cancel off.
Okay.
Yeah. Right, so now we just have sine theta c. So sine theta c is equal to 1 over 1.3. So how are we gonna find for theta c now?
Divide 1 by 1.3.
No. I mean, you already have 1 over 1.3, right? But okay, look at that previous example. Check this out. That previous example. How did we find for r?
We're gonna get the inverse.
Yeah, anytime you find it for angle, you need to use sine inverse. Or cos inverse or tan inverse, but in this case, we're strictly looking at sine, so sine inverse. So theta c would be equal to what?
Sine inverse 1/1.3.
Yes. So plug that into your calculator and you'll figure out the critical angle.
So it is 50.28.
Could somebody else verify that too? 50.28. Somebody verify that. $50.28. Could anybody else verify that? Sine inverse at 1/1.3.
Yes, sir, I got that.
Proceed.
Yes, sir.
So in other words, guys, if the angle of incidence is 50.28 degrees, what's the angle of refraction? Here what I'm saying again, right?
90 degrees.
90 degrees.
Okay, yes, I answered correctly. So let me make a little note about that, right? So if the angle of incidence is 50.28 degrees, for water to air, then the angle of refraction would be what?
90 degrees.
Right. Therefore, it would say that 50.28 degrees is the critical angle. Therefore, 50.28 degrees is the critical angle. And so therefore, you would say theta C is equal to 50.28. Cool. They might ask you to explain this phenomenon. They might ask you to explain critical angle and total internal reflection. You'll have to give them this real rundown. You should also know this. They might ask you to find a critical angle from water to air. Do we understand it? Yeah or no?
Yes, sir.
All right, bet. Yeah. All right. So let's do a passive question now, shall we? The tricky one. So, Amira, read 4B for me. Actually, I call Amira plenty. Let me call upon Nikolai Marash.
Exactly.
Nikolai Marash. I didn't hear from you in a while, Nikolai. He's my partner. Didn't hear from you in a while. The other Nikolai.
Yes, yes, sir.
Nikolai, what going on?
Feeling sick, very sir.
You feeling sick because of the physics or because I call upon you?
Overall, everything.
Overall, everything. If you don't understand anything I was doing before, you had to tell me now, because I'm gonna ask you to do a tricky question, wouldn't I? No.
Eh, I don't think you choose the right person for that.
You don't think I choose the right person? All right, here what? I'll do the question with somebody else and then I'll review it with you. But are you actually sick? That's the question. Or are you just Like, I don't want to do this question. That's the question. Oh, I think Nikolai should do the question. Let me hear from the class. What do you think? Why this class so quiet for, boy? Like, I really had a wonder.
I feel so.
Yeah.
I would say I would have to do the question because sickness can't stop you from learning. But if you're really sick and you can't do it, then no problem, say.
All right. Well, Nikolai, let me do the question. I mean, you had your exam just now, eh? You have your exam in what, like in less than 2 months. So you should do this. Give it a read from a Nikolai.
Figure 3 shows the clownfish Nemo looking at point B. It sees the fisherman's net appears as if it were at A. Calculate angle C given that angle ABD is 42 degrees.
Right. So the way to calculate angle C, given that angle ABD is 42 degrees. That's actually real simple, you know. Like, I swear that's real simple. This is a maths question. First things first, guys. What do you think this angle here would be? What do you think the angle would be?
90 degrees.
Whoa, no, that wouldn't be 90 degrees. I'm not
You
judging.
talking about the one above 42?
Wait, let me draw it back again. I'm talking about this, what angle would be, like for that line. What's the angle for a line?
180 degrees.
180? I feel like I overtake it.
Nah, it's one, Amira is 180, right? For a
Oh,
straight line, the angle is 180. Amira?
Okay, so
You understand that one now? Talk to me.
yes, sir, yes, sir.
Okay. So this is 180 degrees, right? So my question is, if this is 180 degrees, we're gonna use that to figure out for this. Trust. So Amira, what do you think this angle is?
180 minus 42.
Wait. Nah, you're overthinking it. This angle over here, what are looking like?
So I don't know.
Anybody else could see it?
90 degrees.
90 degrees, sir.
All right, so Amira, we had to get onto that, right?
So I just say 90 and you tell me wrong.
That's because I was talking about this.
All right, sir.
I wasn't talking about this. Yeah. I feel like it have a little bit of miscommunication, and I feel like I sensing some like resentment. We okay,
So
right?
I should be good enough.
We good? Amira,
Yes, sir.
you're not gonna find man, shoot man thing, right?
So you never know, you know.
Hey, Ole, if I die, just know it's Amira fault, eh? It's Amira fault. Yeah. But he's staying quiet. Them scared of you too, or what? Way.
Also, I
I
just
feel like the
questioning.
victim.
That's I just questioning how she say you never know. Like
Yeah,
she
but
have that thought.
So I am the victim.
I feel he was Bruce, dog. I feel like he was Bruce. I feel like Nemo right now. Wait, boy, I feel like he gonna bite me. But you see, the thing is, I don't see why. Like, okay, I I don't think you're a victim, eh? Because the first question I asked everybody, what is angle will be? No, that's a straight line. That's not 90 degrees.
So I didn't know you was outlining the line. I thought you were talking about like next to the sea.
Oh, okay. Well, next time I'll do this. Make it a bit more obvious. Sorry about that. But yeah. So this is 90 degrees, right? Yeah. This is 90 degrees. We have
Yeah,
90 degrees here.
that's it.
And
Yes, sir.
Amira, what angle is this?
So like the whole thing.
Like yeah, this was the angle. That
Um,
was the angle along a line.
180.
Right. That's 180. You seen it when like me want to make sure that you understand. So like watch. I have a full circle here. I have a full circle here, right? A full circle is 360. But if I have a line, I'm gonna cut that in half. Come on a second. So you can see that for a line, the angle is actually 180 degrees.
So I understand.
Bet. So guys, if this is 42 here, this is 90. What am I gonna find for C?
90 plus 42 minus 180, or 180 minus the result of 9 is 42.
Perfect. So 180 degrees minus 90 plus 42 degrees. And what would you get?
48 degrees, sir.
Now I have a question for you, right? Over here. Now, this question is very confusing. It's very confusing, right? But Nikolai, if Nemo is looking up at this point and he's seeing something in air, you're really going from water to air. Now, Nikolai, if you're going from water to air and you see an angle of 48 degrees, is that the critical angle or less than the critical angle?
Less.
Yes, less than the critical angle. But we'll see how this question goes. I mean, it's looking like it's a critical angle though, but we'll see. Maybe they give a different refractive index or something. We'll see. But that's the answer for C. Everybody understand that? 48 degrees? Let me know if I like catch that.
Yes, sir.
Yes,
Yes,
sir.
sir.
That is 3 marks. You know how you have to work for 3 marks in maths? Like in a maths exam, I'll have any idea how hard you have to grind for that. It's crazy.
Yeah.
But in physics, I mean, it's really easy to get 3 marks. So angle C is 48 degrees. Right. So, Nikolai, read part 2 for me.
Given that angle C is the critical angle for the air water boundary, calculate the refractive index of the water.
So Nikolai, you see this? Yeah, you see it's a bit different here, right? Because C is actually 48 degrees for this in this instance. Right. So Nikolai, how you want to proceed with this question? Let me hear. How would you proceed with this question?
We use the same formula we use. Is Ni over sine. I mean Ni sin I equals to Ni sin I.
All right. You must share a trick.
Yes, sir.
All right. So at the critical angle, remind me, what is R supposed to be equal to?
90 degrees.
Yeah, R is supposed to be 90 degrees. So let's plug that in and see how it starts to look. What is sine 90?
1.
Yeah, it's taken up with 1 by NR, which is just NR. Understand?
Yes, sir.
Right. Okay. And here what, right? Like I said, this question a little confusing because you see in the direction of the arrows. But if Nemo is looking at this point, then we could treat that really as we could really treat it as the incident ray. Let me show you what I mean by that. So let me just draw this in quickly. And there's also a very simple formula you could use. N is equal to 1 over sine t, I believe. But I will show you this as well. Yeah, so Nikolai, check this out, right? Let me just say that this angle, this is the this is the incident ray, right? Incident ray. What's the angle here?
48 degrees.
48 degrees. And right now it's at the boundary line. So this is 90 degrees, right?
Yes, sir.
And we know that this is water. And this is
Air.
right. What's the refractive index of water? Do we know? Nah, we don't know. We don't know in this question. Right? What's the refractive index of air?
90.
That's always what?
1.
Yeah, it's always one, right? The refractive index of air is always one. We could say that this is the incident ray and this is the refracted. So let me apply those concepts, Nikolai. So Ni is going to be the refractive index for the incident ray. Where's the incident ray?
48 degrees.
Where is it? Where's the incident ray? Is it in air or water?
The water.
Right, so that will be NW. You understand why I said that, right? Because the incident ray is in water. So NW. And what is my critical angle?
90 degrees.
Nah, that's not the critical angle.
Ah, my bad, sir.
What's the critical angle? Remind me. It was given in the question. Well, we had to find it, but
If the 42 degrees or something.
no. C. Calculate angle C. And we calculated angle C to be 48 degrees. That's the critical angle.
Ah, okay. Okay, sir.
And that'll be equal to NR. What was NR? So like NR would be the refractive index for the refracted ray.
Which is 1.
1. So if I want to find for NW now, that would just be 1 over what?
The sine 48.
Yeah. And there you go.
1.34, sir. Or 1.35.
1.35. Now you probably realize that is a bit different from the one we was dealing with. If you notice, like when we did the proof, I told you that the refractive index for water was what?
1.3.
Yes, you see it's slightly different because of different refractive index. Now this is a long way to do it if you forget the other formula which I'm about to show you. But there's another formula, which is just n is equal to 1 all over sine c, where c is the critical angle. So Nikolai, I'm not sure if you're seeing this for yourself, right? But isn't that what we eventually proved? 1 over, like we eventually got there, 1 over sine 48, which is essentially this formula.
Yes, sir.
Yeah. Now let me just go over this one more time because I feel like we're all confused. And I feel like I'll just gonna memorize this formula. Anytime you're trying to find refractive index and they give you a critical angle, you use this formula. This is the simplest thing. N is equal to 1 over sine c. Get your answer one time. But Nikolai, let me run through this thing one more time, right? Let me just say you forget this formula in the exam. Let me just say you forget this formula. First things first, guys. The critical angle and total internal reflection could only happen when you're going from a what to a what. More dense, less dense, what? Tell me, guys. It could only happen when you're going from a what to a what.
More than
More
Celestine.
than
Right, so I hope I'll understand why I flip around the arrows. The arrows was looking like this, but I flip it around now. Because for it to happen, you need to be going from a more dense to a less dense. So I redrew my diagram like this. Because we had to go from water to air for that to happen.
So the question read wrong.
No, the question didn't draw it wrong. They just draw it to confuse you. Because it depends on perspective, right? It depends on perspective. Zachary, think of it like this. if the fish is looking up at this point, then that's technically the incident ray, and this would be the refracted ray because Zachary, the net. Okay, this question real confusing. Let me try to like explain it here properly. So in the question, they were saying that Nemo was looking at point B, and it sees the fisherman's net appearing as if it were at A. So right now, the fish seeing the net as if it was over here, but the net is actually over here. So, Zachary, when you look at this question, the fishing net actually by the boundary line.
Yes, sir.
Because I mean, Nemo seeing it as if it was over here, but the fishing net actually over here. It's at the boundary line. This is a really weird question. But it's not wrong. It's not wrong because if the fishing net is over here and it's directly along the boundary line, it would send a light ray and Nemo would see it over here. It's not wrong, but like you could look at it in a different context. And that context is like this. Now let me explain this, right? When we think of total internal reflection or critical angle, and we think of the light source coming from in the water, let's look
Yes,
at
sir.
let's look at the previous example. Let's look at the previous example. Where was the incident ray coming from? The incident ray was
In the
coming,
water, sir.
right. It coming from the water, but like this one a bit strange because you have the net at the boundary line. The net is over there. So it's a bit confusing. Yeah, it's a bit confusing, but it's like the same scenario, just expressed in a different way. Now, you could think of that exactly like this. You could think of it as if it was this. Like I know it like it's real weird. It's very weird. But you could think of this diagram as if it was this. Because for
Yes, sir.
total, because for total internal reflection to happen and for the critical angle to happen, you need to be going from a what to a what?
More than still less dense.
Right. So another way you could draw the diagram is from water to air. That's another way you could think about it. And so the angle would still be 48 degrees. That's a critical angle. And this will be 90 degrees. Because the fissure net is 90 degrees from the normal. It's kind of weird,
So
but
the incident rate is from in the water.
yeah. If you consider
Right,
it.
sir.
So
So
what?
if I do it the other way, would I get wrong?
It wouldn't work out because you could
Yeah, because
it is only happen. It is only happen when you go in from a more dense to a less dense.
right, sir.
It's only happen like that. Like I could show you what would happen. We could mess around and see, right? And so, Zachary, once you figure that out, you're gonna use this formula. Ni sin I is equal to Nr sin R. At the critical angle, what's the angle of refraction?
90 degrees.
Right. So that I replace I with C and I replace R with 90. You confused?
Now, sir.
Okay, good. Because the critical angle is just the incident ray, right? I mean, it's just the angular incidence.
Yeah.
All right. Next thing, sine 90 is 1. So 1 by NR is just NR. Now we're going to substitute. Now, I said that the incident ray, we are thinking about it as if the incident ray is in the water. So if that is the case, then my refractive index for Ni is going to be for water. So that's going to be NW. You understand?
Yes, sir.
So here's again, right? Ni is the refractive index for wherever the incident ray is. The incident ray, we are assuming it is in water. So I use that as NW. and the critical angle was 48. So I'll say NW sine 48, and that's equal to NR. Now NR, okay, how I get NR to be 1? Well, Zachary, if we assuming that the refracted ray is in A, then where's the refractive index for A?
1, 2.
Right, so I replace NR with 1. And from here, where's the only thing I have to find for?
Refractive index of the water.
Right, which is just NW is equal to 1 over sine 48, and I get NW is equal to 1.35. And that's the answer.
Yes, sir.
That's
Yes,
like
I understand.
that's like a long working if you forget this formula. So anytime they ask you to find the refractive index or something, and they give you the critical angle, this is the formula I would use. Now this formula is only applicable for the air to water boundary. Now the reason I'm saying that, Nikolai, if it wasn't air to water, Nikolai, you understand that air to water, air, the refractive index of air is 1. You understand that, right? Nikolai,
Me or the next one?
you. The refractive
Oh,
index for water is 1, right?
yes, sir.
If it was going from like glass to water, you think the formula for N would be the same?
No.
No, because somewhere in your working, right? When you reach this point, would it still be 1 or would it be like 1.5 or something? It'd be something different.
Because the glass would have been more dense than air.
Exactly. So you'd end up with a different formula. So this formula is only applicable for the air to water boundary. Yeah.
Yes.
So anytime you see a question like this, my advice is just use this formula. If you do forget, you could derive it like use any long method I would have showed you all, but try to remember this. So for most people in class, I'll just go and use this. I understand. So let me explain it one more time and we'll move on. So part 2 said, given that the angle C is the critical angle for the air to water boundary, calculate the refractive index of the water. So they want us to find the refractive index of the water. Anytime they're asking you to find the refractive index of water for the air to water boundary, this is the formula you could use. N is equal to 1 over sine C. So Amira, C is just the critical angle. So Amira, what did they say the critical angle was?
The critical angle. So, like any question or like
In this question.
is the angle for the air to water boundary?
Nah, like in part 1, what do we find? In part 1, look at part 1. What did we find for in part 1?
So you can repeat
What did we find for in part 1?
critical angle,
Right, what was the critical angle?
48 degrees.
Right, so if you're using this formula, it'll just be N is equal to 1 over sine what?
Sine 48.
Yeah, and you get your answer without doing all of this. But yeah, remember this formula though, the specific case. And yeah, you get the 1.35. Yeah. So I'll make a note about this. Right? For the air to water boundary, right? And Nikolai, do you remember the formula? So it can be found by N is equal to
Oh, 1 over sine C.
Right, 1 over
I
sine.
was just not talking, sir, and my mic wasn't on, and I was saying, sir, you hear me?
Well, that's okay. And Nikolai, we could verify this, right? Now, in the proof above, like when we was doing the theory, we said that the critical angle will be 50.28, but that is when the refractive index for is what? That only happens when the refractive index is what? For water is what?
90.
No,
What?
this
1.3. My bad.
1.3, right? Good. So if I use this formula, right, and I say 1 over sine 50.28, what's supposed to get?
Is it supposed to get 90 degrees?
Mm-mm.
Oh,
This formula allows us to find the refractive index of water for the air to water boundary. So here, plug it into your calculator and you'll tell me what you get. Plug it into your calculator and you'll tell me.
you'll give me 1.3, not the 90. Okay.
That 90 is the angular refraction, right?
Okay, sir.
This formula is an easy way to find the refractive index of water for the air to water boundary. You just need the critical angle. That's all. So remember this.
Yes, sir.
Okay. I feel like plenty are real confused, like real confused, especially
You
after
say you can go back. I wanna take down the statement.
you want to tell you the exam, yeah?
I just wanna take down the notes.
Okay, which note? The one above or this one?
The one you was just at.
No problem.
Yeah.
Right, so for the air to water boundary, the refractive index of water could be found by n is equal to 1 over sine c.
That's it.
Right. So I'll explain the question again, because I feel like a lot of us are confused. So let me run through this thing one more time. But if you understand this, just do this, right? I will let you just get all your marks. What I'm going to show you all is what to do if you forget this, like to derive it in the exam. But anytime they ask you to find the refractive index of water for the air to water boundary, this is the formula to use. N is equal to 1 over sine c. You can answer one time. Vani, are you there?
Yes.
Right, so Vani, you ever see this formula before? Or nah? You ever do this in school?
Nah, I never seen it before.
Okay, well, now you know. So Vani, total incident reflection and the critical angle only happens when you're going from a what medium to a what medium. So check the notes.
Modern.
Nah, it only happens when it goes from a more dense to a less than, a less dense. More dense to a less dense. More dense to a less dense. So I'm going to take this diagram and I'm going to redraw it. So I'm going to say that my angle of incidence is 48 degrees here. If you recall, in the first question, we found 48 degrees. Yeah?
Yeah.
Right? So this is 48 degrees. And we're going to, if this is a critical angle, right? Vani, if this is a critical angle, if 48 degrees is a critical angle, then what would the angular refraction be for that?
90.
Right. So like, Zachary, this will clear up any confusion that is there. Zachary, you there?
Yes, sir.
Right. So Zachary, I want you to forget about this diagram, right? Forget about this. Forget about that. You forget about it?
Yes, sir.
All right. So Zachary, if the critical angle is 48 degrees, then we know that if the angle is 48 degrees, what's the angular refraction?
90 degrees.
Right. You understand the diagram now?
Yes, sir.
So like everybody in class, if the critical angle is 48 degrees, then what the angular refraction has to be?
Ninety degrees.
So one,
Now, Amira, at the critical angle, what's the angular refraction?
90 degrees.
Right. Check back the notes. We know that. We know that. Check it out here. So the critical angle is the angle that causes the refracted ray to bend 90 degrees away from the normal. So at the critical angle, the angular refraction is 90 degrees. And so Amira, if you want, you could pull aside and you could draw a separate diagram. So Amira, at the critical angle, which is 48 degrees, the angular refraction could be 90 degrees. You understand that?
Yes, sir.
All right, cool. And in this question, they want us to find the refractive index of the water. Cool. So Vani, let's do that quickly. But Vani, you understand the diagram or like you're real confused? You,
Yes, I understand.
you're sure, like, if you're confused at all, just tell me,
No, I understand.
Okay, I take any word for it. So if you forget this formula, n is equal to 1 over sine c, what formula would you use?
And sine I is equal to NR sine
Ni sine I is equal to nr sine r. Right. Now, where's the incident ray? Tell me, Vani, where's the incident ray? Right. If it's in water, then the refractive index is going to be NW. Make sense?
Yeah.
All right. Do we know what the angle of incidence is?
48 degrees.
Right. Do we know what the refractive index for the refracted ray is?
No.
Yeah, we do. Where's the refracted ray? Vani, where's the
No.
refracted?
90 degrees, sorry.
Where's the refracted ray? It didn't go down in the waters yet, so right now you'll think of it as if it is in what?
It's in the air.
It's in air, right?
Yeah.
So what would NR be? What would NR be?
90 degrees.
Now, NR is not angular. NR is the refractive
Oh,
index.
no. Yeah.
So NR would be what?
1.
NR would be 1. What's the angular refraction?
90 degrees.
Right, Vani, let me know if that makes sense.
Yeah, it makes sense.
Because Vani, at the critical angle, what is the angular refraction?
90.
Yes. So do you understand why we said that R was 90?
Yes, sir.
All right, let's simplify this thing now. What is 1 sine 90?
1.
1. How would I find for NW?
1 over sine 48.
Yeah, 1 over sine 48 degrees. And you get your answer one time, plug and take calculator, you should get 1.35.
Yes, sir.
Or you understand the other, like the long way better? I don't know, guys. I think they did a really bad job with this diagram. I feel like it's real confusing. It's real confusing. Yeah. Um, if you are still confused, let me know. If you understand, let me know as well, so I could see how everybody feeling.
Yes, I understand.
All right.
I understand.
Drew,
I understand, sir.
Drew, you understand this?
Yes, sir.
All right, so Drew, let me do a little recap, right? So Drew, for total internal reflection and the critical angle to happen, you need to be going from a what medium to a what medium,
More than less than.
right? So you need to be going from more to less. So in the case of air and water, you need to be going from where to where?
Water to air.
Right, water to air. Now, if you're going from a more to a less, the refracted ray would bend towards or away?
Away.
Bend away, right? And eventually, if you keep increasing the angular incidence, it's gonna cause it to be 90 degrees to the normal,
Yes, sir.
right? So you call this the critical angle at that point, bam, and so at the critical angle, the angular refraction is
90 degrees.
great. So in this question, the critical angle was 48 degrees. Yeah,
Mm-hmm.
and we was going from water to air, and so this is the incident ray, this is the refracted ray, and so I would say that Ni is equal to Nw, and Nr would be equal to what?
Huh? Oh, the
Yeah, the
refractive
refract,
index of water.
and this could just be the refractive index of air, right?
Oh yeah, yeah. Sorry. Yeah.
So we're on the same page, right? Like, so the
Mm-hmm.
Ni would just be Nw because Ni is asking us the refractive index wherever the incident ray is in. The incident ray in water, so Nw. The refracted ray is technically in air, so the refractive index for that will be Na because it's in air. And
Mm-hmm.
from there, you just use Ni sin R. Ni sin I is equal to Nr sin R, and you make Nw the subject of the formula. Understand?
Yep.
Great. Don't worry about this diagram. Diagram kind of confusing. Yeah. Cool. And if you remember the shortcut, just use the shortcut. N is equal to 1 over sin C. You get your answer one time. Right. We okay with this question? 6 marks. Well, truth be told, is actually 12 marks here. Well, let me tell you how much this whole question is worth. So 12, 15 marks. This question by itself is 15 marks. 15 marks by itself. It's this whole question. Just asking, do you all remember the laws of refraction? Yes or no? Do you all remember the laws of refraction?
Normal is perpendicular to the boundary line.
Right? The normal is perpendicular to the boundary line. That's one.
The light waves bend when they pass through different medium.
Exactly, that's
The
one.
light waves bend when they pass through a different medium as a result of the light traveling at different speeds.
Right, and you had to state Snell's law. So Ni sin I is equal to Nr sin R. Right?
Yes.
And then you had a then what's the last one? The last one was with the crazy
The
diagram.
angle of incidence and the angle of refraction lie on opposite sides of the normal, but all lie on the same plane.
Right. Yes. That's the one with the three-dimensional diagram. Yeah. Yeah. So both of them lying on the same plane, but they're opposite sides of the normal. Yeah. Excellent. So like Oliver will be getting 15 marks. But wait, let me lock those other 3 marks in the bag, right? Let me lock those 3 marks in. So Shayna, read part 3 for me.
Nemo swims and his eyes now is horizontal distance of 5 meters from point B. Looking at point B, he no longer sees the net but now sees Bruce, the shark. If Bruce is at the same depth as Nemo, how far is Bruce's eyes from Nemo's eye? Explain your results.
This is so funny, yeah? It's like suspense. Here it is. Looking at point B, he no longer sees the net, but now sees Bruce, the shark. Oh, that's also funny. I don't know why that's funny. It's like he now sees Bruce, the shark. But this shark got no teeth. Let me put some teeth for this shark. Are they want to put grills on the shark? Let me know, guys. So they want to put
Yes, sir.
We'll let you
Yes, sir.
artistic vision.
what color all they want the grills to be? What color all they want the grills to be?
Yellow. Yeah, brush your teeth in a while.
There's no grills, but all right. No wonder Nemo running away. I feel like Nemo more running away because of his breath than anything else.
Yes, sir. He should
Yes,
put
sir.
some mouthwash on them things, sir.
Wait there. Yeah. Right. So,
Facts right there.
say that again.
The facts are right there.
Yeah, this is the facts, right? This is why Nemo running. Because truth be told, Bruce don't even have any teeth. Why Nemo running for? Must be he breath. You know what I mean? Because I think some, okay, are any sharks? Wait. Let me not say something stupid. Are any sharks? Okay, yeah, it have some species of shark that are omnivorous and herbivorous. I didn't know that. But yeah. Oh, you know that? That some sharks actually eat plants. Did you guys know that?
No. Nope.
Ah, sir.
Yeah, like the bonnet head shark is the only shark species that is a omnivore. So it consume large amount of seagrass. That's interesting. I could have swear all sharks were carnivores, but you know. Maybe Bruce is an omnivore. Who knows? All right. I think this
Yes, sir.
I think this answer like real simple. What so they're asking us how far how far is Bruce's eye from Nemo's eye? I think all of us know the answer. What's the answer?
10
Hello.
meters.
10.
10, right? No, let me understand why. Quickly, let me understand why. So Nemo swims away. If Nemo swims away, what happen? So like watch. Imagine Nemo was over here, right? Imagine Nemo was over here.
So the angular incidence would increase and the angular refraction would go into the water, causing it to reflect.
Zachary, you gonna mash up that. Hey, that exam already for Zachary, but nah. Zachary a goated boy. So I hope we can see that, right? If Nemo is over here, then when he was over there, what was the angle? Remind me from the last question. When he was over there, what was the angle?
90 degrees.
No.
Oh, this? Oh, that? Oh,
Watch.
that angle. 248.
Yeah, Nemo, and that
So,
angle was
refraction. My bad, sir.
that's okay, and that angle was called the what? That was the what angle?
The critical angle.
Yeah. Guys, remember this is a critical angle. Anytime we go past the critical angle, what does happen?
Total internal reflection.
Right. So when Nemo moves further away, it's gonna cause the angle to get bigger than the critical angle. So this angle over here is going to be this angle over here, theta I, is gonna be more than theta C. So therefore you're gonna have total internal reflection. We understand that?
Yes, sir.
Yeah. And this could be theta R. Let me know if we understand this. Everybody in class.
Yes, sir.
I bet. I want to hear Nikolai and Zachary and Sheena, like I want to hear like a few hours. I really don't know what's going on. Are they not eating enough food or something? I need to like carry all for food or something, are they?
Yes, sir. I don't mind.
Yes, I think so.
Yeah,
You know,
but
Laura,
some
but
other
this
people
sounds
might be
curiosity.
cheap. I don't know what to say.
Look, you see,
And in
as
this
soon as I talk about food, look all they talking. Way, boy. Nah, 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 nah. Kind of thing is this, boy? Yeah. But like, what they want though? Like, if I were to carry a little, what they want? What they want to eat?
so if you carry somebody showing in this class to eat, your money might done. So I don't recommend that.
I might just buy a box of KFC or something, like a big box of KFC. I mean, I'll be fine. Be fine.
Yes, I don't mind that. So
So
very good.
morning, I'm vegetarian. So
You're vegetarian, well, I see. Okay, no, I wouldn't. If you're vegetarian, I probably still wouldn't buy anything from KFC, even though KFC claims it's vegetarian, because most likely they're frying it in the same oil and thing. You'll get you get like Mario's or something. You get like pizza. Oli-
I'm vegetarian, so thank you.
Oliver, I feel like Oliver's maturing and all. They like maturing, so I'm outside children. Not that I have any children, but Oliver's my outside children. If that makes sense. No, Oliver would be maturing because Oliver's my lesson children. Anybody else would be my outside
Yes,
children.
sir.
You all are maturing. That makes sense. So I had to feed maturing. I had to feed maturing. I can't leave Oliver. I can't just go for milk and never come back. That'll be sad. That'll be sad.
So I was not gonna say something like that, sir.
Nah, I'm not Tivon. I'm not Tivon. I don't leave my kids behind, Poor Romano. Yeah. Romano has been sad because his father leave him. Yeah, boy. True,
Yeah.
let's see. Nah, boy, Drew, boy. A watermelon, boy. Hey, that's kind of, yo. uh, I don't want to encourage racist jokes. I feel um, like the milk is just like a universal thing of like father leaving now. I don't feel like it's racial anymore. I feel like it's like an open expression now. I'm not
I
racist,
feel
guys,
like
and I don't encourage
I feel
racism.
like more like in between, sir.
I
I
just say
feel
I don't encourage racism, man. I don't encourage racism. Yeah.
no, but on the whole, it is like in between.
I feel so, yeah. Like let me not say anything controversial because I was gonna say that Indians would like leave to go get a bottle of punch and um but I know I best I just don't record. I don't know, I can't post this on YouTube, boy. I can't post this on YouTube.
Yes, sir.
Hey boy. But you know what I mean different stereotypes. But
Yes, sir.
all right. So let me just write the answer. Let me write the answer for this quickly. The answer is 10 because Bruce Brett stinks. Write a proper answer. If Nemo swims further away, the critical angle would be exceeded, resulting in what? Resulting in what? Somebody tell me, resulting in what?
Total internal reflection.
Right. Right. As such, do we understand that?
Yes, sir.
Yes, sir.
Okay. So here what? Next class, moving on to lenses for sure. I think we do enough Snell's law questions. What I do want you to do, I think you should be able to handle this question now. So here what I want you to do. I want you to do this question for homework. And if you don't do it for homework, I'll have to talk to your parent. But if you're learning something in class, I would hate to see you just forget it next class. So take a screenshot of this for me. Take a screenshot. I want you to take a screenshot and put it in the chat and say homework. So you know it's homework. So take a screenshot of this, put it in the chat, and say homework in bold. And Olia, don't be like Bruce. Go and brush your teeth after class. Because I know some Olia wake up just now.
Nah, I doubt there's some people inside this class here, sir.
Say that again?
I doubt there's some people in this class here. Can't be learning physics and you like that.
Well, I mean, Bruce trying to eat Nemo and Bruce I brush your teeth, so I mean,
Okay, so you have a possibility then. Who's that in this class here?
anybody,
Anybody goes?
anybody just like get up and they just start class and they gonna brush their teeth after class. No shame, no shame.
I said that
Yes.
would be shame because it could be posted up on YouTube.
Oh
And
yeah.
whoever.
All right. And take a screenshot of this. Thank you, Vani. Thank you, Nikolai and Vani. Good job, guys. Take a screenshot of it and put it in the chat. I see anything big. I like that. I like that. Jadon, since you see it in big, I should see the answer in big. You know what I mean? I should see your attempt in big.
100%. 100%.
Right? Take a screenshot of this now. You see the thing, guys, it has so much different ways it could bring the same question. I sure there are a lot of content, but it's up to you to do past paper questions and like see if you truly understand everything. You need to lock in and try to do questions in physics.
Yeah, sir.
All right, more 19 marks for this question and 19 marks. Yeah. Telling you guys, you could get close to 20 marks for Snell's law, fast Snell's law question. It's crazy. That's like 1/5 of your marks. It is 1/5 of your marks, bro. Come on, get our 20 marks. I'll take the screenshot.
Yes, sir.
All right, cool. Now here what, right? This question is going to give some of you all problems. Because I know when they say calculate the gradient end of the graph and then they ask you what physical quantity does it represent, I know most of you are going to be stunned. So to help all you, I just gonna highlight something, right? In one of the classes, we went through all the formulas you need to know for refractive index. All these are formulas you need to know. So n is equal to speed of light in air over speed of light in medium. N is equal to wavelength in air over wavelength in the medium, right? Ni sin I is equal to Nr sin R. We love that one. And then number 4, Nr is equal to sin I over sin R. I have a question, guys. If I were to plot a graph of sin I versus sin R, what do you think the gradient would be?
Sin A over sin R.
Right, which represents what? Which represents what? Okay, if you're confused, remember the gradient. When you do gradient, right? Gradient is change in y over change in x. On the y-axis, we have sin I, and on the x-axis, you have sin R. So by you finding gradient, you're effectively finding sin I over sin R. And sin I over sin R is equal to what?
NR.
which is
Refractive index.
right. So when you do any question, don't act like you don't know what to do. We cover every single thing in class. Like we cover every single thing. We look at all the formulas. We do multiple questions. We went through everything in detail. It's there. You just gotta look at the notes. You just gotta go through the notes and look for it. Right? Cool. So that's it for class today. I didn't know what I have to do for homework, so I expect to get those things for homework so that we could finally put a pin in Snell's law. Great. So next class, lenses. I didn't know what lenses is involved.
As with the object distance and the magnification and all those sorts of stuff.
Yes. I have really good notes on it. Look me at her. Legendary. Yeah, boy. Memory boy. This is bringing out memory lane. I could send these notes. This is like past notes I had on waves and optics. Going through every single thing. So like this is what we're gonna be like in our next class. Convex lens, convex lens, and concave lenses. So I'll send these notes. So yeah, guys, hope you have a blessed Saturday. Take care.
Bye, sir. Same to you, sir.
Later.
Yeah, later. So